Welcome back. In this lecture we will discuss the logistic function as a way to represent conditional probabilities. So let's go back to our definition of a conditional probability. We have probability of H given some evidence equals the conjunction divided by the prior of the evidence. So that's pretty straightforward. We can further rewrite the denominator as the probability of H and the evidence plus the probability of not H in the evidence. And this is, clearly true, and we actually did this in an earlier example. So then we can just, assuming that the probability of H and the evidence occurring together is greater than 0, we could divide both those two items being summed in the denominator by the probability of H and the evidence occurring together. So that now becomes 1 plus a quantity that is often referred to as the odds. And we can just manipulate that further algebraically to get this expression, which is known as the logistic function, because we have sigmoid log of the odds gives us, as a result. So we can plot this as a curve, and it gives us this nice logistic curve that is quite common. The other thing, in future lectures we will talk about why this is useful, because it is differentiable, and that is used in a technique both called logistic regression as well as with deep neural networks that use a sigmoid activation function. So anyway, that concludes our lecture on the logistic function. Please stay tuned for more content.